Okay, welcome back to Precalculus. In these lectures, we're going to study the functions. What is a function? So our main goal is to determine whether a relation is a function. So we start with an example here. We have a set of order pairs, 1, 3, 1, 6, 2, 6, 3, 9, 3, 12, and 4, 12. Here we say we can express, normally when we have order pairs, the two values here, the first value will be the x value and the second value will be the y value. It's two-dimensional again. We are discussing precalculus. So based on this, we can see that the order pairs we have 1, 1, 2, 3, 3, 4. So this means our first, which we will call the domain values for the order pairs is 1, 2, 3, 4, which is again called the domain. Normally, the domain of a function will be the x values. And 3, 6, 9, 6, 12, 12. Again, these are the second values of the order pairs. This is the y values, which also we call the range of the relation. Now, figure 1.1 shows how we plot the domain with the range, the effect of it. So, for example, the domain 1, based on the order pairs here, we can say 1 generate 3 and 6. 1 generate 3 and 6, 2 generate only 6, 3 generate 6 and 12, and 4 generate only 12. So again, our x values are called the domain, and the y value, which is the second values, are called the range. Now, based on this, we can say that an equation frequently expresses how the second component, which is the output, in this case, the output is the range, is obtained from the first component, which is the input. In this case, will be the domain. Now, if each value of x, which is again the domain, put into an equation, result in one value of y, then we say that the equation express y is a function of x. So that's the definition of a function. A function is a relation between two sets such that to each element of the domain input, there corresponds exactly one element of the range output. So a function may be defined by a set of order pairs, a table, a graph, or an equation. Now, when a function is defined, the variable that represents the numbers, which we call the domain or input, also is called the independent variable of the function. And then the variable that represents the numbers in the range or the output is called the dependent variable because the x values determine the y values or the domain determine. So if we have equation y equal to 4x minus 3, the value of y depends on the value of x. So if x is 1, then y will be 1 because it will be 4 times 1 minus 3. If s is 2, 4 times 2 is 8 minus 3 is 5. So if s is 2, y will be 5. Now let's check if this function or this expression given to us is a function. So here we say does y squared equal to 2x express y as a function of x? Our answer will be no, because some values of x are associated with more than one value of y. Because we have y squared equal to 2x. Now, secondly, also example given here, if x is 8, then y can give us 4 or negative 4. Because if s is 8, we get square root of 16. 2 times 8 is 16. So square root of 16 can be positive or negative 4. So this means, again, y is not a function of x. So here, equation y squared equal to 2 express a relation between s and y. There's a relationship here between s and y, but y is not a function of x. So here we have some order pair a and b. Our first value is a, second value is b. And we know the quadrant, the first quadrant, always the x and y values are positive. The second quadrant, x is negative, y is positive. The third quadrant, both are negative, s and y. And the fourth quadrant, x is positive, y is negative. So they give us some few points here. And our goal is to determine some few rules here. First rule said that if we have order pair a and b and a and c, a and b and c and d, They can be equal only if A is equal to C and B equal to D. Now, the graph of an equation that defines a function or relation, here we say is the picture that results when we plot the points whose coordinate S, Y satisfy the equation. Now, to sketch the graph, we can plot enough points to suggest the shape of the graph and also draw a smooth curve through the points. This is called the point plotting method of sketching a graph. Next, we can also test, as we saw earlier, as first example, we can determine whether a function or an expression given to us, say y is a function of x, by saying that if x value can give us more than one y value, like if s is 8, from the y square equal to, I think it's 2x. If s is 8, we get y square equal to 16, which means y equal to square root of 16, which can be positive or negative 4, so it's not a function. Another way of doing testing, also we can use what we call the vertical line test. A vertical line test means if we plot a graph and we draw a vertical line, if the intersection is only 1, then y is a function of x. If it's more than 1, then it's not. So for example, we have a function y equal to 4x squared. We came up with some few s values. We're able to determine y values. For example, if s is -1, -1 squared will give me +1 times 4 will give me 4. If s is -half, -halves square will give me +1/4. 1/4 times 4 will give me 1, +1, etc. So we're able to plot. Now, if we draw the line, the vertical line across this, we only get one intersection. So we can say that this function, y is a function of x. Now, secondly, we have y. This is again y equal to 4x squared. Second, we have y squared equal to 2x. So we came up with some x values. For example, if s is -1, then y will be 4. Why? Because -1, we're going to square, etc. We have half, 0, 0, etc. Now, when we plot, this is what we get. Now we see that this is not a function, because when we draw a vertical line, we get more than one intersection. So y is not a function of x. So here we say we can see that the vertical line test indicates this is not a function, as we already saw in example 1. For example, a vertical line at s equal to 2 will intersect twice. The first was y equal to 4x squared. We can see this is a function. A vertical line only intersection is only once at any range of the function. So that's the whole concept here. Our main goal of these lectures is to go through what is a function and what we mean by if we have two variables and y and x is our domain, y is our range, what we mean by saying y is a function of x. So again, see you in the next lectures, and thank you for your time.